Welcome back to this next part in the series. I'm going to start off by modelling the wings, but before that, I'm going to talk a little bit about airfoils and their uses and choosing one. Typically, RC models use a Clark Y airfoil, and that's just because it has the typical characteristics for a low Reynolds number for flying and producing lift. And so I've taken this airfoil, and when I put it into Java foil, I get a 2D coefficient of lift for the Reynolds numbers that it will typically fly at. And I take those results and I can convert them into a 3D airfoil. So an airfoil is a two-dimensional section, and the coefficient of lift reduces when that becomes a three-dimension due to tip vortices and other parts that cause drag and extra issues. This is still a very simplified version of 2D to 3D conversion, but it's basically giving us Newton lift values at different angles of attack. And here we can see the typical Reynolds numbers. We get sort of 5, 6, 3, 4, 5, 6 newtons of lift, which should be enough to fly if we can keep the weight down of the whole aircraft. Hopefully, you can see here this is as the Reynolds number is increasing, which basically means that the faster we go, the more lift we get, and it's at quite a low angle of attack, 4 degrees, 4 or 5 degrees of angle of attack. So this, in conjunction with a few motors, should help up the speed enough to get enough lift to fly reliably. So having said that, I've taken the airfoil coordinates and I've converted those into the top. I've sped up this last part of the clip because I already have a whole series on designing and printing wings, and that's quite a good place to start. So all I'm doing in this is basically the same. So I'm importing my airfoil, placing it where I want it to go, and then I'm using three-dimensional sketches to decide where the airfoil should loft to. So I'm using a surface loft, and then all it does is follow that. So I'm using the reference from the side plane and the top plane to see whereabouts vertically on the body the wing joins, and also to see what sort of taper anhedral the aircraft wing follows. And then all I do is loft the surface to follow that shape. And then at the very end, I just use the surface trim tool to trim out the internal cross section where it follows the body, and that just lets the whole thing stay as a single surface. So if you want to learn more about this, check out my other videos on wings. If not, then the rest of the video is just going to be silent and a fast forward of how I got to the end result.